Then once the gel is solidified in the casting tray, the tape what you have placed at both the closed open ends has to be removed, and this casting tray along with the agarose gel has to be placed in the electrophoretic chamber. Now you can see the gel has been placed in the electrophoretic tank. Now any electrophoretic apparatus have two ends, one is cathode end, the other is anode end. Now you can see the wells that are formed. Once after the gel is solidified, we will remove the gel comb from the casting tray that makes the wells to be formed in the gel. Depending on the teeth of the gel comb, the number of wells that will be formed in the gel. Now imagine like this is the teeth 1, 2, 3, 4, 5, 6, 7. I can ensure that 7 wells can be formed using that particular kind of comb. Now this combs comes in various types, like it can be 16 well, it can be 32 well, sometimes it can also be 60 well. Depending on the number of samples what you want to run in the process, you can choose a particular type of gel comb. Now once after the comb is selected and you prepared your gel, now you will be ready to load your DNA in the wells. So these are the wells if I prefer multi gel combs. If not, if I use only one gel comb, that has to be as close towards the cathode end. Why? Because always the DNA or proteins which are most commonly negatively charged in nature, they are placed towards cathode and they are made to move towards the anode. And you have to ensure that your electrophoretic buffer should be depth of the gel of at least 1 millimeter. Hence this can be otherwise called as submarine or submerged gel electrophoresis. Agarose gel electrophoresis is otherwise called as submerged or submarine gel electrophoresis. Mean that your gel should get immersed in the buffer solution. Your gel should not be on the top of your buffer solution. Why? Because once after that you are loading your DNA sample. When you load this DNA sample, it has to move along with the buffer in the electrophoresis process. And you should also be ensured that you should not load your sample before your gel gets immersed. If you do like that, your sample will come out from the well of the agarose gel. So this has to be taken care. Next, coming to loading the gel, you have to place the pipette tip over the well, means your tip should go inside the well, and then you have to release your sample. The sample should sink into the well, means it has to sit in the well, and you have to be sure that you should not disturb the well like puncturing the gel with the tip. Why? Because tips are little bit sharper, so there is a never chance for the gel get pierced. And coming to the running of the gel, as we already mentioned, like you can start at 50 volts. Why? Because the sample have been loaded in the well. Imagine this is the sample. The sample should not come out of the well. To ensure that, we always start at low. We'll start at low voltage. Once the sample comes out of the well and enters into the agarose matrix, you can extend this at 100 volts or 120 volts depending on the type of the power pack what we use. Now this is how we see the movement of the DNA molecule. These are not the DNA molecules, these are called as the tracking dye. You can't see the DNA or protein that is loaded in any kind of the gel because all biological macromolecules are colorless in nature. Hence, we need some kind of a tracking dye that tracks the movement of your biomolecules. So this tracking dye most commonly used is a bromophenol blue dye, where you can see the movement colored in blue, a little bit also a violet. This is one more kind of dye that is called as orthocrysal. Now why we choose this is because bromophenol blue is quite less in molecular weight, they move faster, which is of around 300 base pair. By that time your DNA is somewhere located in between this area. Depending on the type of the DNA you choose, you can run this by parallelly running a DNA ladder or a DNA marker. The DNA markers are of different sizes you can get from any vendor, and you can run parallel to the chosen or the unknown sample. Now this is the important thing what you have to remember, that is the agarose gel percentages. Now what percentage of the gel I have to choose depends on what is the molecular weight of my isolated or purified DNA molecules. If you don't have any idea about your isolated DNA, you can choose these three preferred agarose percentage gels. If you know the molecular weight, then a corresponding ideal agarose gel percentages which is listed can be preferred. And finally, once the molecules move on the gel, you can stain the gel to check whether your DNA is present or not. This is commonly done by choosing different types of staining dyes. One most preferred is ethidium bromide. There are some alternate safe DNA stains like cyber green and so. Why? Because ethidium bromide is an mutagen, but ethidium bromide is a quick process where you can complete the process in no time. This is what about the agarose gel electrophoresis. Thank you.